What I did here was something a little bit sneaky. I made a common denominator by multiplying the first one by m plus 1 over m plus 1. I mean m1 plus m2 over m1 plus m2 to make a common fraction. And so if I multiply that out, I've got m1 squared plus 2m1 m2 plus m2 squared minus m1 squared minus m2 squared divided by m1 plus m2. Something beautiful happens. The squared terms cancel. And we're left with 2m1 m2 divided by m1 plus m2. And I've lost my g. I got 17. I've lost my G. I got 17.1 newtons from that. Is that wrong?
I did it about 17.3, but then the book says 34.
34, huh? That's twice this.
Yeah. So I don't know if I just did the square.
Yeah?
The equation they used was 4 times m1 m2 g over m1 plus m2.
4 times m1,
I don't know how they got
they get a 4 there, huh? Four, huh? If I had made a sign error, oh. I think the devil's in the details here. I think that this should have worked. This should have ended up working out so that we got a 4m1 m2, and it is likely that it could be that this formula is not accurate. Like I could have, if we somehow flip the sign here somewhere, that could end up getting us a 4 instead of a 2. I don't see it right off, but and I'm taking this on faith that that's the correct thing. It could be that it was supposed to be. But that makes sense to me, given that if M1 is bigger, if M1 is larger than M2, then A should be positive. That's the case here. So this formula makes sense for that picture. So I don't think that's wrong.
If you solve for A and plug it back in, you can get the right answer.
So you found the A, plugged it in there, and you got the right answer? So my algebra is wrong, right? Then my algebra is wrong. My algebra can be wrong. I'm allowed. So you guys actually just calculated this directly and then plugged that into here. And you got 34? Okay. Let me stop. I don't see what's wrong with what I did, but you know what? That's fine. It doesn't matter if I see what's wrong with what I did or not. What matters is that we have, this is the physics, right? Newton's law, Newton's law. Identify what you're looking for, which is T1 plus T2. And then we just have to go back to put things together. Wow, this problem's a lot harder than I thought it was when I signed it. I'll tell you that. So, other questions? Yeah? Yes?
Will the test questions be very similar to these forms of questions, but just in
I think that if you do these questions, it should prepare you for the test questions. Will they be exactly the same? Probably some, but maybe not all. You know, I might change something from pushing to pulling, something like that, you know. I might inadvertently, accidentally make the inclined plane go this way, whereas it was going that way, or something stupid like that, you know. So, I don't know. Other questions? So this question, I don't like as a test question unless it has extra guidance, right? Like, I feel like there should be an A and a B here. Part A should be find the acceleration. Part B should be something like, explain why the tensions in each of the cables are not equal. That's just like a kind way of making sure you don't assume that T equals T, which would get you, I don't know, get you somewhere. It would be a good place. And then maybe part C is find the tension in the hanging cable. Yeah. Yep.
Is it safe to say that the normal force will always be mg if it's not an incline?
No, it is not safe to say that. Let me show you an example where it's not the case. So suppose, I'm glad you asked that, if we've got a box like so, and maybe he's pulling like this, right? And maybe I tell you that the angle off the vertical, just to mix it up a little bit, if I tell you this angle looks like, I don't know, 70 degrees, yeah? Then you can say, you know, find the normal force on the box. If the coefficient of kinetic friction, well, let's say mu sub s equals to 0.5 and mu sub k equals to 0.2. So I can ask questions like, does it move, right? And let's make F naught equal to, I don't know, 100 newtons. And let's give ourselves a mass of, what do you want? 20 kilograms. By the way, I'm sorry I don't have quiz 2 back to you guys yet. I should have impressed on the grader that it needed to be back today. Unfortunately, that didn't happen. So what I'll probably do, and if you don't want to be included in this, just send me an email so I'll take it out. But I'll tell the grader to leave them on like a chair outside my office, which is next to the physics lab. So you can just go and I'll try to have him put them in alphabetical order so it's not too much of a hassle. And you can just go pick it up there when he's done. I will announce once they're sitting there. But that should happen at the latest by Monday, all right? So you should at least have that to look at. I posted a video solution of quiz 2 earlier today. I intend to scan my work for that and give you a PDF of that in the course content sometime soon. I just haven't gotten to it yet. All right, so this one here, if you look at the free body diagram, well, we got what? We've got F naughts like that, right? But we've got mg, we've got the normal force, and we've got two pieces, right? We've got F naught. In this case, notice the angle here, right? So this is 70, yeah? So that is actually F naught sine 70 as I have it currently situated. And he's pulling. And this guy would be F naught cosine 70 in my current setup. And then the force of friction would be this way, right? So we have that, so vertically, we have Fn, well, 0, right, equals the normal force plus F naught cosine 70 minus mg, right? So my normal force apparently is equal to 100, well, it's equal to mg minus F naught cosine 70, which makes a lot of sense, right? If you were to pull up on the box, you're kind of like, in some sense, reducing its weight a little bit, at least with the part of the pulling which is vertical, yeah? And cosine 70 accounts for that here. So, whatever that works out to, the normal force would be, what did I say, 20 kilograms times 9.8 minus 100 newtons times the cosine of 70. What's my normal force? Lost my... Oh, there it is. Sad. It's right here the whole time. All right, 20 times 9.8. So his weight is 196 newtons. So this gives me a normal force of 96 newtons, which of course is not equal to the weight, right? To answer your question. Here's an example where the normal force is not equal to the weight. And then to go further with this, the question is, does it move or not, right? So horizontally, we have that mass times acceleration is what? What's the horizontal story here? Well, possibly F naught sine 70, yeah? We've got that pulling force, and then minus the force of friction, yeah? So, let's see here. So how do you decide whether or not it's moving? How much force do you need to start moving? How do we figure out what that tipping point is? Moving starts when A is still 0, right? And mu sub s was what? Was it? What was it? 0.5. And then the normal force is what? 96 newtons. Is that what, you know, is that, well, I shouldn't say that. That's not the way to say it. I don't want to say 0 is equal to that. That's not what I'm saying at all. This is the max. This is the max static friction. The max static friction is yeah?
Why is the vertical using cosine?
Because I just find the angle to be right here. So, I mean, it's this picture, the 70 is here. That's the hypotenuse. So that makes this 100 cosine 70. And that makes this 100 sine 70. Yeah. Now, this is the max static friction. How much is it? 0.5 times 96. So the max that static friction has to offer is about 48 newtons. We've got more than, well, I don't know how many newtons do we have. What is F naught sine of 70? .93. I mean, it's about 94 newtons. So definitely this is larger than that, right? So in other words, we've got enough force that we've overcome the static weld and we're moving. So we're in the case of kinetic. So just to write it down here, 94 newtons is greater than F static max, which was 48 newtons, all right? So moving, yeah? So we're moving, and then the equation we have to solve is, it's right up here. It's MA equals to 94 newtons minus, what is mu k? 0.2. That's the coefficient of kinetic friction, 0.2 times the normal force, which was 96 newtons. And so that tells you that the acceleration here which is what I would have probably asked for you to find, yeah. I typically will say find the normal force and the acceleration for such a problem. That's a good set of questions for this problem. Tells me a lot if you understand or not. 94 minus 0.2 times 96 gives me 74.8. What was the mass? 20. So I divide by 20. I get acceleration of 3.74 meters per second squared. So there you go. Another example. We've done this with pushing before. Now I did it with pulling. And I also mixed it up. I put the angle off the vertical, right? Watch out for that. That's a popular thing to do on a physics test, is to give you an angle like it hasn't been given before to see if you're thinking through it, or if you're just assuming things like just because it's vertical it has to be sine, just because it's horizontal it has to be cosine. That is not the case. We have to think about the trigonometry. Anyway, that's it. See you Tuesday.